session, we are going to see how to create RO systems step by step. We will introduce, or I will show you how to introduce the water analysis, the water source sample treatment, introduction of parameters, the create RO configurations, the design tools of the software, and other useful functions. Also, we will see the report options that you have or you can find in our software. Okay, what is QPlus? QPlus is a membrane projection software from LG Chem. This software estimates the membrane performance under variable conditions. This is a multifunctional, user-friendly platform. Why you should use QPlus? This software is used to design and optimize RO membrane systems, compare performance against competitor, and calculate energy and water savings, and compare with other different designs. This software could be used by LG engineers, O&Ms, consultants, in general, to anyone who wants to create and design RO systems. You can find the software in our webpage, www.lgwatersolutions.com. If you go to tools, you will find the software option with the last version, and you also can find a QPlus installation troubleshooting guide. If you have any problem, you can check in that file to try to solve the problem. If you can't, you have a contact person to write in case you have problems with the installation or with the software. Okay, we are going to see how to create RO systems and the tools through the QPlus software directly. So if you install the software and you open it, you will find this interface of the software. And in the main screen, you will find in the top the information of the project and the toolbar. And also in the left side, you will find the parameters and the option to change language and unit. And the process diagram. Also here in the bottom of the screen, you can find a bar where you can open different or several files of QPlus software, QPlus files. So this is very useful because you can have here several or a lot of different files, and you can modify everyone, and you have here all the ones. So I'm going to start explaining with an easy example how to create RO system. After that, I will explain you all the tools, the tools that you have or you can find in the toolbar in the top of the screen. Okay, so the first thing that you are going to do when you start to design a RO system is to introduce the project information. Okay, so here you can introduce the project name, the case, the customer, and the username. The date will be automatically set by the software. So the next step will be introduction to introduce the or select the feed source. So if you click in feed source, you will see here the different water source that you can find in the software by default. Here you can find the water classified by type of water or type of feed source, and also classified by the fouling potential. So you can find, for example, RO permeate water, well water, surface water, and seawater with different fouling potential, and also wastewater. So if, for example, we select seawater open intake with SDA less than 5, you will see in this window that you have, by default, the flow loss and solid passage increase. These values are set by default for the software depending on the fouling potential. If we see, for example, a seawater well with SDA less than 3, we see that fouling potential is lower. This is because when the fouling potential is higher, that means that you have to do more cleanings during a year than if you have lower fouling potential. So the degradation of the membranes will be higher. And then the flow loss per year and salt passage increase per year will be higher when the fouling potential is higher. So additionally, if you select the membrane age, for example, 3.0, you will see that the flow factor will be automatically set, because the flow factor depends on the membrane age and the flow loss. My colleague Alvaro already explained the meaning of those parameters in the previous webinar. But as he explained, the flow factor will be calculated depending on the membrane age, that for first pass is typically between 3 and 3.5, and for second pass it's around 4, maximum 4. And this will affect to the maximum, to the feed pressure of your system, because with the years, when the flow factor is higher, means that the flow loss per year will be higher, and this affects to the permeability of the membrane. So when the membranes are degraded because of the pass of the years, the permeability will be less. So to have the same permeate flow, you have to apply more pressure in the high pressure pump because of the membrane degradation. Okay, once we have selected the feed source, in this case, we are going to consider seawater intake with SDA less than 5, that typically corresponds to open intake and conventional pretreatment. We have to go to introduce the water profile. Here you can introduce ion by ion the water analysis, and also you have several water analysis by default. So if we take one, you can find here the seawater analysis that you have introduced and the balance analysis. When you introduce the seawater analysis, you have to balance it with all ions, all cations, or ions, or if you want, you can balance the analysis with specified ions. For example, sodium chloride. So you can click here, sodium chloride, and the water will be balanced only with sodium chloride. When you create one water analysis, you will have by default for the next project, when you save the analysis, you will have it each time that you open the software. So when you click here, you will have all the analysis that you have created and also the ones that you have by default in the software. You have the option of manage the seawater analysis. So you can add new ones, you can delete. Okay. Next step is to set the temperature and pH. So here you can modify the temperature and the pH case by case. So I will maintain 25 degrees and pH 8. In the membrane H, you can see here that we have 3 years of MLT that we have set previously. If you add a new path, we will have here the option to set the second pass membrane age. So I will set to 4 years. That is the maximum that we consider typically for second pass. And then we will set the flow rate. For first pass, you should you should set 2 parameters. You can set feed flow and permeate flow, or feed flow and concentrate flow, what you want, but you have to select 2. So in this case, I'm going to consider 100,000 cubic meters per day. So let me change the unit. So here you can change the temperature, the flow rate in American or metric units, also pressure and flux. So I will maintain in metric units, and I will change to cubic meters per day. And I will set 100,000 cubic meters per day, and I will set the first pass to 45% recovery. In the second pass, I'm going to set 90% recovery. And in this case, you only have to introduce 1 parameter. So once you have introduced the 3 parameters, 2 for that you have pass and 1 for second pass, you will see here the flows for the rest of the parameters already calculated by the software. For the flux, it's 0 because we didn't set the configuration yet. So now we are going to start creating the process line. And in the first pass, to calculate the number of pressure vessels, we need to set the number of elements that we are going to consider for each pressure vessel, typically 6, 7, or 8. I'm going to consider 7 elements per pressure vessel, that is the most typical design, and taking into account the total permeate flow of the first pass and the typical average flux depending on the type of feed source and type of pretreatment, we select the average flux as per the guideline. I will show you later where you can find our guidelines for the main parameters of the RO system. So for this case, for seawater with open intake and conventional pretreatment, we typically use 13 LMH. So if we take 13 LMH and with the total permeate flow that we have set and 7 elements per pressure vessels, and the area of the membrane that we are going to select, in this case, we will select 440 elements, you can get the number of pressure vessels that you need. So in this case, I have calculated 1,120. And we are going to select the model. For this first pass, we are going to create a hybrid design. To create a hybrid design, we first select the membrane of the first element. We are going to do a hybrid design with LG seawater 440 GR and LG seawater 440R. We are going to make a hybrid 3-4. So I select the first model. I select the number of elements that I want to introduce of GR elements and click on. And we select the next model. That will be 440R. Okay, this first pass is done. So we are going to go to second pass. In the second pass, we are going to add one stage to improve the global recovery of this second pass. And here we are going to also consider 7 elements per pressure vessel. And the configuration here will be 240 in first stage and 8 elements in second stage, with elements, brackish water elements of low energy. That is LG brackish water 440 AS. And for the second stage, I will take the same. Here I took calculation between first and second stage around 3.1. And if you see here, you can find the values, average values for flux. You can see here that the average flux in the second pass is high. Is higher than typical or maximum typical flux in the second pass. So let's see the design tool that we have, because I did this selection because we are going to introduce the option of permeate split. So I will explain one by one all the options, but let me start with permeate split. So for this case, I'm going to introduce here an permeate front side split or 20%. Sorry. I don't know what happened. Let me check. Okay, sorry. Now you see that when we have bypassed 20% on the front side split, we have now lower average flux in the second pass. So maximum, as per the guideline that I will show you later, is 34 LMH. So now we are okay. In this case, for a front side split, we can use the blended of this part of the permeate with the final permeate, or you can use bypass. If you click on bypass, you will have a bypass of the split, but we are not going to mix this part of the split with the final second pass permeate. Okay, when you select permeate split, you see that you have two options: the option of a front side split and the total permeate split. In this case, typically we use this split, front side split, because the permeate that we get from the first element of the pressure vessel has lower permeate TDS, because the feed TDS to those elements is lower. So along the pressure vessel, the feed TDS to the tail elements will have higher TDS. So the permeate of those tail elements will have higher TDS. So to improve the size of the second pass, this is the most interesting option. But you have also the option to bypass or to make the split or blend the part of the final permeate or phase or of the first pass with the second pass with the final permeate without taking the front side split. But with this option, we can improve the second pass side because the split that we get from the first elements will be better than the mixed or the final permeate if we don't take the first element permeate. Okay, so we have also the option to introduce the chemical dosing in the first pass or in the second pass. So we are going to introduce a second pass dosing in the feed flow. For example, sodium hydroxide, we set the pH that we want in this case to improve the boron rejection. So only setting the pH and selecting the chemical, you will see here in the process diagram the symbol of the chemical dosing. The recirculation, you can make recirculation in these streams, but I will introduce the typical recirculation that we make in this kind of system. Typically, the 100% of the total brine flow of the second pass will be recirculated to the first pass, because with this we improve the water quality, or we decrease the total TDS to the first pass, because the TDS of the concentration of the second pass has lower TDS than the raw water. And also we can save in raw water flow when recirculating the current or the stream of the brine of the second pass. Okay, the blending option is when only it's applicable when we have one pass. So let me show you. If I create a new project, and you will see here, and you click on blending, you can select the stream, the flow that you want to bypass, and a part of the raw water will be directly sent to the final permeate and mixed with the permeate of the first pass. This is typically used in brackish water system when the water, the feed water is not the salinity or the TDS of the feed water is not very high. It's brackish water, and the final permeate is not requirement. The final permeate requirement is not so tight. Okay, let's continue with the previous design. Okay, booster pressure, you can click on booster pressure and you will see the symbol of the booster pump in between the stages. In this case, we have only 2 stages, but if we have more than 2, 3, or 4, you can see the symbol in between every 2 stages. So you click on the booster pressure and select this and set the pressure that you need. This is typically to balance the flow, and you should set depending on the system configuration and the requirements. You can see here the interstage booster pump. The back pressure is typically used when you need to set or we need to establish a pressure in the permeate because it's required by process, because you have to send to a tank or to any discharge point, and you have to take into account the pressure losses and the height. So in the RO system to be taken into account by the pump. Also, it's typically used in system when you have several stages, like in second pass, when you need to balance, in some cases, depending on the conditions, the flow between the stages. So let me set here, for example, 1.5 bar. Imagine that we need 1.5 bar in the final permit to send to the tank. Okay, we have also the option to introduce in the process diagram an energy recovery device. You can select isobaric or turbocharger. If we click on isobaric, that is the most typical. You can change some parameters, main parameters of the system, and you can see here the volumetric mixing. This mixing will affect to the salinity increase by your energy recovery device. So typically the salinity increase for by the energy recovery device is between 2.4, 2.7, depends on the condition. So to set the salinity increase that you are looking for, you should change the volumetric mixing, and when you have ready the system and you run the projection, you can calculate what is the value of a salinity increase that corresponds to 6% of volumetric mixing. Okay, so you can see here the energy recovery device. And the last tool is the interstage pressure losses. This is when you want to consider a pressure, an extra pressure in the high pressure pump because of the pressure losses between stages. So if you want to introduce in the high pressure pump the pressure losses that you have calculated between the stages, you can set here, and the pump will increase the feed pressure according to those values. Okay, I think we have our system ready. We can run the projection, and let's see what happened. Okay, in this case, we don't have any warning. When you have warning, you will see here in the eye of information, you can see it in red color when you have a warning. So here you can see the RO feed, the permeate flow, flux, recovery, pressure drop, and so on for every element in the pressure vessel. So if you have any warning because of high flux in the first element or high recovery in any element, you will see here the symbol in red. For example, I'm going to decrease the number of pressure vessels to get the warning. Okay, you see, now we have a warning because the flux in the first element is higher than the maximum established by the guideline for this kind of water. So now we have to try to mitigate the warning or remove it if we can. So in this case, you see the average flux is also higher than the maximum or typical value. So we come back to 240, and we run again. We remove the warning. Okay, now we have ready the projection with no warnings. We have calculated it, and we have several options. So in design detail, you will find the complete design report. You can export to PDF or you can export to Excel file. Here you will have all the information of the projection for first and second pass, including the analysis, the adjusted feed with the circulation, and also the salinity increase of the energy recovery device, the permeate that we get in the feed, and this is the front side split quality. This is the tail permeate quality that will go to the second pass. And if you see, the TDS is better in the feed end or in the front side permeate. And also you can see here the balance inside the pressure vessel. And the same for second pass. Okay, if you have any warning, you will see here also. Here we don't have any warning. But if we have high flux warning or high recovery or any other warning, you will see here. Also, you can find the solubility calculation in the feed and concentration. You are not going to get any warning about solubility, but you can see here the percentage of solubility for feed and concentrate flows. Same for second pass. You can see here the balance of the flows within the vessels, first and second stage, and same for solubility and the warning. Okay, we have two very useful functions that other softwares don't have. That is the batch calculate and summary. For batch calculate, it's used when you want to run projections or a lot of projections with different conditions to see the different operation points. So I will go to more simply an example simpler. Depending on the conditions. So for lower temperature, typically the speed is higher, and then typically we adjust the number of trains in operation in the second pass, depending on the flow that is arriving to this pass. So for this kind of system, it's not so useful, but because you have to optimize case by case manually. But when you have system like this with one pass and you don't have to touch it, only you have to see the different pressures and quality depending on temperature and pH or membrane age. You can apply the batch calculate. In batch calculate, you can select single variable or customized conditions. In single variable, you can only modify one variable each time. So for example, if we want to get projections from 25 degrees to 35 degrees, and we have an increment of 5 degrees, we will get projections to 25 degrees, 30 degrees, and 35 degrees. You can change the value from a starting point and ending point and the increment, whatever you want. And you will have the projections done directly by the software in a folder that you select. I will run this example. Okay. In the folder, you will have this projections automatically in PDF. You can do it with only one variable here in this option, and you can change pH or membrane age. But you also have the option to click on Customize Conditions and select the condition one by one, all the parameters. You can change feed temperature, pH, even the feed type or feed analysis, feed water analysis, and the membrane age for each condition independently, up to 7 conditions. And you will have these 7 conditions projections in PDF in the folder that you select. So this is very useful when you when the system doesn't change. I mean, doesn't have a split or different number of trains, etc. So you only want to take operation condition like feed pressures and see the quality with different conditions. You can do it like that, and it will be very fast, very useful. And we have another powerful tool that is design summary. In this case, it's different because for the option of batch calculate, you only need one Q+ file to run a lot of projections. But in this case, you need to have one file for every condition to get the design summary. Let me show you the example. In this example, for example, I have created 4 files for each condition. For 35 degrees and 3 years, for 35 degrees and 0 years, for 25 degrees and 3 years, and for 25 degrees and 0 years. So you can upload, you can select up to 25 files and start calculate, sorry, and you will get this summary. Here you have a summary of these 4 conditions, and you will see here the main parameters, feed pressure, quality, and so on. So you can run here, or you can do the summary with up to 25 files. But you need one file, Q+ file for each condition. So it's different. Okay, about the software and the reports, that is all. But let me show you some more tools that you can find in our software. In the main toolbar here, in the top, you can find the option of load any Q+ file. Remember that when we send you Q+ file for you to run, you should load. You should start first the software and then load the Q+ file from the computer. If you click on the file, probably it will not run. You can save with the name or save as with different name. This is useful when you are going to you want to create a summary and you need to create several files. You can duplicate projects. You will see here all the projects. This is also very useful, and other software don't have this option. You will see here how the case 1 is created, and now you can change the condition, for example, 30 degrees, and save as with the different name. So you can change name and save. So you have here a new Q+ file that will be used for summary. You can also load 2.4 versions of the Q+. You can create new project. This is to create a new You project here and you can reset the parameters if you have already introduced the parameter in the new file. In the design tab, you can find also the option of the feed source. This is the same that I have explained before. This is the same than this one, same option, same information, and water profile. Also the same. You can find here, or you can find here in the main screen. Okay, the same information. And this is also very useful when you don't have a lot of experience using our software, and it's the first time you can use this wizard option. And with this option, the software will guide you along all the process of creating the system. See, the first step, project information. So from here, you can introduce project information, select the unit, select the water source. Next, the water profile you can introduce from here, the flow rate, the energy recovery device, and the final configuration. So from here, if you don't have experience using our software, you can use this option your first time, and the software will guide you step by step. Design tool already seen. In edit, you have the ion composition. Again, the same information about the water analysis that you have saved in the software. And another useful tool is product. Here you can see all our products, but also you can add new products. The new products can be our products or real membranes with information that you have of the membranes in a plant. If, for example, the permeate flow, because of the degradation of the membranes, is different, also the rejection, and you have the information and you want to check the performance, the current performance of those membranes, you can create the membranes including the name and all this information, the diameter, the rejection, the flow, and so on. And you can run projection with other membranes. And also with competitor membranes. You can create, having the information, you know that you normally have all this information from the specification of the data sheet. So you can create membranes of the competitors and run projection and comparison with our membrane. In properties, you can find the information of the software. You can find the product specification. This will we'll go to our web page and technical documents and data sheets, and here you can find the data sheet of seawater membranes and brackish water membranes. You can download it. And from here you can find the information to create new products. If, for example, if in your version you don't have a second generation membrane, you can download the data sheet from here and you can introduce the parameters or the specification that software asks you to create the membrane and save the membranes. Those elements that you have created, you will have it always that you open the software. It's not going to be deleted every time. So it will be, they will be saved in the software. This is also very useful. If you click on guidelines, you will get the design guidelines for the main parameters of the RO system depending on the type of water. So here you can see the different type of waters and the fouling potential. And depending on the fouling potential, you can have the average system flux to design your system. This will be used to calculate the number of pressure vessels that you need in your system to maintain the flux as per this guideline and the type of water. So, for example, we have used seawater with conventional pretreatment, and we have used like a normal fouling potential, and we have taken certain LMH for our design. Okay, for second pass is RO permeate, so we took around 34 LMH. So you can find here the guideline in metric and also in American units. And the last option is our home page. Here you can find all the technical documents, the tools. Also, this is very useful. Also, this option in products in comparable LG product locator, you can select the competitor and select the product, and it will tell you the equivalent membrane of LG. Okay, so that is all for my side. I'm going to leave you a couple of minutes to write your questions in the question tab, and I will answer them in a couple of minutes. Thank you.